When I was little, parents would tuck me in and would say goodnight, sleep well, and see you tomorrow. Back then, I was so little I didn't understand that sleep well was 2 words. One night, when I was sick, Mom would stay up with me and make me soup. She'd look at the time and she said that we couldn't say see you tomorrow anymore because it was already tomorrow. We know we live on a giant rock that we call Earth. And we know the Earth is part of a solar system along with 7 others. Sorry, Pluto. And that these planets are orbiting a star that we call the Sun. The day is defined by the area facing that sun, the night by the area facing away. If only it was so simple, this would be the end, but the universe has it that keeping track of things requires constant supervision. First things first, the sun doesn't actually rise and set. It's the Earth rotating about its axis. Either way, this phenomenon would create the illusion of days following in order and what our fundamental understanding of time is based upon. Today, for example, would be today, regardless of what the day is, and our relationship with today, or perhaps time in general. But what is a day in the first place? Since everything in the universe is moving around in one way or the other, there are at least 2 ways to answer this question. The first thing we need either way is a reference. A meridian is a line of longitude extending north and south from where you are located right now. According to this line, you know what sunrise and noon and sunset to you. As seen from the North Pole, the Earth rotates counterclockwise once every 23.9 hours relative to faraway stars. This is called a sidereal day. But the Earth also revolves around the Sun, and some more rotation is needed for that same meridian to line back up with the Sun. This longer day, if you will, is the 24-hour solar day, from when the Sun is highest in the sky until it's highest in the sky again. Got it? Good. Modern clocks are only based on the average solar day because of 2 main factors. The first is that the Earth's orbit is elliptical because of gravity, and because it's not dealing with any friction floating around in space. An orbit is actually a body, see planet, in freefall, but without ever hitting the ground. This might be difficult to imagine if you have never left the Earth, but when a body moves along another and reaches orbital speed, or traveling faster than you're falling, the surface area underneath literally curves away from it. The gravitational pull from the Sun increases as the Earth gets closer, but its speed picks up as a result. This means that the closer we are to the Sun, the longer the Earth travels over the course of 24 hours as opposed to when it's further away. By coincidence, we happen to live at a time when these forces cancel each other out. The other factor is the analemma, and that is the Sun's position in the sky every day at noon throughout the year. This happens because the Earth is tilted relative to its spin, and in return why we experience seasons. This means that during the months of summer, the Sun illuminates the northern hemisphere more than the southern, which means more hours of sunlight over the course of a solar day. The longest one of these are known as the summer solstice on June 20th. Vice versa, during the months of winter, the North Pole is tilted away from the Sun, giving less hours of sunlight, with the winter solstice on December 22nd. Now, if the Earth had been spinning the other way around, would time go backwards? No. Reverse motion can give us the idea.
But those are recorded still.
Images playing back in the opposite order. This became a great phenomenon in 1896 when the Lumiere brothers released the world's first film playing in reverse. And since then, shooting in reverse has become a commonly used technique for, safety. The future might not be written, but information is being stored and allows us to make improvements or even prevent things from happening. The present is a moment passing by so quickly that, if you want to be nitpicky, we actually live in the past because the brain needs time to register things as they happen. If you want to be even more nitpicky, it takes light time to travel from an event A to your retina B. This means that everything you see is actually already a tiny bit in the past. In fact, due to this precise nature, time is often considered being the fourth dimension, because the universe as we know it is in constant motion. John Archibald Wheeler said that time is what stops everything from happening at once. We're also pretty sure we cannot make more time, but we can make the most of it. This in contrast with buying time and killing time, like you'd be doing right now. Reading a sentence takes time, and you need to remember how it began to make sense of it. Can you repeat that? If that's a no, then you're up for a treat. For example, was that a giraffe or a zebra on a picture? This may or may not make a whole lot of sense right now, but stick with me. Like we saw in an earlier episode, the memory can be trained because information is being stored or at least written temporarily in relation to brainwave frequency. And if you're within the selection of audience who have been here before, you better know all about it. It's funny, we don't remember the future. But how did this video begin? No, seriously, you can't say you didn't see this coming, it was in the title. Now, it appears to have got ourselves two loose threads. No, it's actually just one. If you're holding on to the giraffe or zebra question, you got that one right. But I need to move on with the narrative. So if you're within the selection of audience whose memory about the opening is, and get this, lost in time, you're gonna have to travel back in time and get it. Just be aware that if you do. Alright? We're approaching the end, and that brings us to relativity. There is the arrow of time, and time dilation, and time management, even whether or not time is only a property, but we'll have to save some of this for later. It was Albert Einstein who discovered that time was like a dimension that's woven into the very fabric of space itself. This four-dimensional space-time continuum has a life completely on its own. This means that time passes for everyone, but at different rates for people in different situations. In terms of relativity, this refers to how fast you're moving through space and thus slower through time, which, even if you do actually travel, is microscopic within the boundaries of the Earth. Except it is truly a matter of non-zero. The warping of space and time in relation to the density of a nearby object had to be taken into account for the GPS system to work properly. Gravity, instead of a black hole for comparison, is infinitely dense, and time would stand completely still. And you'd be dead. Philosophical, on the other hand, is your internal perception relative to the world around you. This in turn shapes your behavior unless you know how to manipulate your own perception, which might just serve you better off. Time, moving fast or slow either way, does not influence you as an individual, but relative to your surroundings. Age in particular. Because that one actually does hold you back until you've been around for a while. This premise tends to change or develop because experience changes interpretation. Restrictions though apply until 18 or 21 or 14. Because regardless of how mature you think you are, age just isn't applicable for negotiation. It's the law. But also, restrictions vary depending on where you are, which leaves a question on age being a number at all. Except the law can and will override your mental age. Now, we aren't done with this by a long shot, and if you actually did rewind back there, you've watched a portion of this video twice, which, for the future though, you can hit L on your keyboard to skip 10 seconds ahead, or tap twice on the right side screen if you're on mobile. Time remains one of the biggest questions that scientists have been unable to answer, and if you found this video interesting, tune back in next month and we can resume where we left off. Thanks for watching.